of course, then where is the beat is a little more variable. You know, even if you're really precise, if you have a lot of pulses before a note, it may move slightly. Beat moves around in music, that's not uncommon. Well, quantization, you can go in there and say, I want it right here. Put it. And that's great, because then everything's on a grid. Also, that sucks, because everything's on a grid. You know, it sounds very unnatural. So you can put other things in to adjust that, randomize that, and then you can also quantize to a, you know, a swing beat.
Oh, yeah.
And like I know with Pro Tools there is like percentage swing, so it's kind of like it's neat. Yeah, that you can set it to be.
How swinging about 35%.
Yeah, I did one song and it didn't work straight, and I tried like a regular just a swing beat. I'm like, no, it's just too over the top. So I think I ended up with like a 20% to 40% swing, and it just gave it a looser feel than regular, but not that rigid kind of swing.
Yeah, what's it? GarageBand's got like, you know, 16 squares for notes and stuff, and then it's got, for 16 and 8 notes, it's got heavy and like smooth.
Okay.
But it's pretty good for fast as well.
Yeah. So yeah, so that makes it a little simpler. Like I said, Pro Tools, you get a percentage. So there's different ways of doing it, and there are other techniques. I'd like to see what kind of automated stuff they have, and that's something I'd be interested in is applying that, because you can quantize not only the locations, but you can also quantize the levels. You know, or if you're drawing it by default, you quantize the levels because you set the levels manually. You're just drawing it on the piano roll. So. Yeah. You know, I'd be really interested in looking into randomization algorithms to make that sound more natural.
When I go in, I sort of like, you know, make a value that I want, but not exactly.
Yeah, the thing is, there should be, it's like there should be a way of doing that, and maybe there is, and I just don't know it. But a way that it could either like look at other tracks to get like some kind of overall envelope information.
Yeah.
And then some kind of random so that each bit, it varies a little bit, but it varies a little bit in a way that sounds natural. You know, that's not just a Gaussian, if a Gaussian doesn't sound natural, or uniform. Well, uniform probably would work. A Gaussian probably would be a good first order guess at what might work.
Yeah.
So, I don't know.
Yeah, I was kind of wondering that, like, mistimed it, maybe mistimed it.
I've heard of some devices that do it. I don't know how they do it. It's probably proprietary. You know, but they'll do that like drum machines. It's common for more expensive drum machines to have that ability to go a little off quantization. And there's probably somebody at the company spent a lot of time investigating that and trying to determine what was a good way of adjusting the quantization so that it could sound more natural. So, okay, so now we'll get to MIDI files. All right, so MIDI files, .mid extension. Well, how do they relate? They are the MIDI standard. They include, you know, all the values. I understand that they include running status. They can embed sysx messages that works. I'm not 100% on how all these work perfectly. There are basically three types of MIDI files. 0 is one multi-channel track. And that would be effectively, if you think about dumping what's on the cable directly to the disk. All the channels go to into the disk, and it's just an absolute recording of what's going over the cable. Whereas file 1, which is more common, is you separate each channel to a separate track. Okay, so even though there's still the channel command in there, because like I said, you're taking the MIDI standard and putting it in a file. And so there's still the channel command inside that stream. It is written separately, so that everything's isolated. And that's more common, we'll see that. And then, but the idea with that is that each of these tracks should be the same length and should be played simultaneously. Okay? Whereas track 2 is kind of a way of specifying sequences, but they're independent. So you may have a bunch of tracks in a type 2 file, but you don't assume that you play them all together. Okay, so MIDI files are all done in chunks. And there are basically two types of chunks. There's header and track. And so in the chunk, you get 4 bytes that tells you what type of chunk it is. So if the first 4 bytes are the ASCII values MTHD, it's a header chunk. If the first 4 bytes are MTRK, it's a track chunk. After that is a 4-byte length value. After that is MIDI data. So there's not much to it. Now, with the header is actually kind of a standard format. So it's got 4 bytes to tell you empty head, 4 bytes to tell you the length, 2 bytes to tell you the file format, 2 bytes to tell you the number of tracks included in a file, and then 2 bytes to tell you the pulses per quarter note. And again, I made the analogy of pulses per quarter note is kind of a sampling rate. It's how many internal clock ticks in this file equals 1 quarter note. And we'll see where that gets used later, because the difference between this and what happens on the cable is that what happens on the cable has no timing information, right? So you hit a note on command, you hold the note, you hit a note off command. There's nothing that comes across the MIDI cable that tells you how long that note was. So what the MIDI file does is it encodes that information. And that's why when we look at a track, we see that the track has 4 bytes to identify the track, 4 bytes to tell the length, and then the delta time since the last event, and then the event. And then these two things repeat off. So it's delta time event, delta time event, delta time event. So at the beginning, your delta time is 0, you have, say, note up. And then if your note off is sometime later, you have the time until that occurs, and then the note off. And we'll see an example of that. Okay. Also embedded, non-MIDI events, also called meta events. Now these are embedded with the FF command. So remember, F is a system command, so these are specific ones. So this includes a lot of things that you would want as part of the file that, again, wouldn't be transmitted over the cable specifically. So for instance, type 1 is an ASCII text message that includes the lyrics. So that's a nice thing. And also you see a .kar file, the karaoke file. I believe that's a slight modification on the MIDI standard to do these kinds of things. So yes, you can embed lyrics, you can embed a copyright notice, you can embed the instrument name, which is useful. You got multi-tracks, one's supposed to be a piano, one's supposed to be a voice. You can include channel references for sysx. You can include the tempo. You can include the time signature. You can include the key. So you can include all these things. So those are useful because, I mean, in some sense, well, what do you need the key for? It's got all the notes it has, and the key can be inferred from that. Well, this is a nice way, if you're going back and forth between this written music to MIDI, MIDI to written music, well, now you've got all that information included in the file. And we'll see that in the example. Okay, so we talked about it. We said, we'll see this as an example. We talked about length, right? So if we're looking at the length between files, how do we specify the length? We can make it as short as 1 byte, and we'll see examples of that where it's just a 1 byte length. Or it can be longer. Well, how do we know if it's 1 byte or more? The way they do it is they do very similar to the way you use that most significant bit to determine between a command and data. They use that to tell you if it's more than 1 length. So basically, the last byte of the differential time has a 0 in the most significant bit. If it requires 2 bytes, the first byte in time, which is the more significant bit, has a 1. It requires 3 bytes, that also has a 1. So everything has a 1 except for least significant byte. So here what you do is you take these bytes, and for instance, here's an example. This particular time is 8300. So those 2 bytes together form the time. Now remember, the high byte is just used to indicate whether or not it's an additional byte. So in this case, we break it out and we say, okay, here's the high bit, here's the data, here's the high bit, here's the data. Okay, this is 0, so this is the least significant bit, our least significant 7 bits. And then we'll take the other 7 bits from that, and we'll rearrange them together so that we put them all together. And then we convert that, and we get 384. And in this particular MIDI file, we say, okay, well, you know, from the header we know that there are 96 pulses per quarter note.